hypothesis tests. So usually you have some kind of claim. And the claim is often a comparison to some known information about a population. That claim leads to a hypothesis. So some example hypotheses, like we went over a minute ago, I might say that college students have less screen time than the average US adult. So the hypothesis related to that in symbols, since I'm using an average, population average is the symbol mu. And then is less than something, I would have to look up or be given what that is. And we were given that it was 6.5 hours per day. So I would say this hypothesis could be stated as mu is less than 6.5. Another example. Average human body temperature is 98.6 degrees Fahrenheit. I'm using an average here, so I would use mu again. This time it's an equal to. And I would say 98.6. Another example. Average BMI of an Oregon resident is at most 28. And I'm not going to worry about the units of BMI right now. We talked about it the other day. Talk about it again in the near future. Okay. And I use the word average again. So guess what symbol I'm going to use? Mu. Notice that when I'm writing down a hypothesis, I never use X bar for an average. It's always based on the population. At most. Ooh, what symbol is for at most? At most 28. Could it be 29? Could it be 27? Could it be 28? Yeah, it could be up to 28. So in this case, at most means less than or equal to 28. So sometimes you get a less than or greater than with the claim. Sometimes you get an equal to. Sometimes you get a less than or equal to. It could be a greater than or equal to. Right? You could get a not equal to. Right? Somebody might say, no. I haven't been a nurse long enough. I've almost never seen somebody with a body temperature of 98.6. It's not 98.6. It's something else for body temperature. All right, so it could be a not equal. It's another option. All right, one more example, and then we'll write down some more tedious stuff. More than 30% of Oregon adults are obese. All right, so do I have an average here? I have a percentage. A percentage came from dividing two things, which is really called a proportion. The symbol for a proportion is a P. Very good P, better P. So here I'm saying P is more than, and I'm going to call it 0.3. So usually when we state it in symbols as a hypothesis, the proportion is stated as a decimal, not a percent, is the way it's usually written. It's not a huge deal, but that would be a hypothesis in notation, where P represents the proportion of Oregon adults who are obese. So each of these has to have a definition to go with it. Next, there are two types of hypotheses. We have what's called a null hypothesis. And the null hypothesis is something that's known about the population. So some known or maybe believed population parameter value. Like the other day, I looked up, based on data from the CDC and the Census Bureau, the percent of Oregonians that are believed to be obese. And I think it was 31%, maybe. I can look it up again. A couple things about the null hypothesis. Again, it's known or believed to be something out of population parameter. That would be like, we think body temperature is 98.6. We think the percent of people in this region that are obese is about 30%. Okay, so that's some known or believed value for something we can measure about a population. Other thing about a null hypothesis, it has to have an equal to in it. So if it must have an equal, when I state it in symbols, then that means I'm either going to see equals, or I'm going to see less than or equals, or I'm going to see a greater than or equals. Those are three possible ways to write a null hypothesis. And for us, it's either going to be a mean or a proportion. So that means it's either going to be a mu or a p. Can you do hypothesis tests with other kinds of statistics like medians and standard deviations? Yep, we don't have time to do all this. So for our null hypothesis, it's either going to have an equal to, less than or equal to, greater than or equal to. And then as far as the parameters that we're going to look at, it's either going to be a mu or it's going to be a p. It's going to be an average or a proportion. Then we have what's called an alternative hypothesis. And an alternative hypothesis is a belief that something is changed in the population. Or some subset of the population. Like we have data on US adults, but we believe US adult college students are a little bit different than US adults in some of their behaviors. So that might lead to an alternative hypothesis. An alternative hypothesis cannot have an equals in it. So possible symbols there would be a not equal, right? A greater than, or a less than. And these are kind of opposites of each other. So if my alternative was a not equal, my null would be an equal. If my alternative was a greater than, the opposite of that would be less than or equal to. If my alternative was a less than, the opposite of being less than is greater than or equal to. So usually they go together in that order. According to STAT243 for simplicity, they almost always choose, somehow I'm missing my tools to color stuff. They almost always use equals for the null hypothesis. And the alternative could be any of the others. So we have to set up a null hypothesis. We have to set up an alternative hypothesis. They're always going to be based on a population parameter. And the population parameter for us in this class is going to be either mu or it's going to be p. Right? And what does that mean? It means we're talking about a mean or a proportion. And the hypotheses always reference the population. When we do the test, then we have to compare to the sample. So next thing, types of tests. We're going to end up with 3 types of tests. We're either going to do a left tail test. That would be if the alternative hypothesis, the way we abbreviate alternative hypothesis is H for hypothesis, and usually an A for alternative. If my hypothesis was something like P is less than whatever number, I would do a left tail. Could be a 2-tail test. It would be a 2-tail test if the alternative hypothesis was something like mu is not equal to whatever number. And then we might do a right tail test. And we know we're doing a right tail test. Again, if we look at the alternative hypothesis, that's what dictates this, the alternative. And that would be something like a mu or a p is greater than whatever number we started with. So to determine the type of test, is either left tail, 2-tail, or right tail. It's based on 2 things: the alternative hypothesis and the population parameter. Okay, and we have that inequality. Alternative is either less than, greater than, or not equal to. So those are the basics of the hypothesis test. So we have to determine what our hypotheses are. We have to determine what kind of test we're going to do, left, to, or mid, or right. And then what we do is we actually run the test, and to make a conclusion is based on what we call the p-value. And the p-value comes from comparing the sample statistic to the population parameter. So sample versus population. If the p-value is less than the significance level, right, that's what I called alpha before, then that implies the evidence supports the alternative. However, if the p-value is bigger than the significance level alpha, that implies the evidence does not support the alternative. And we have to get used to loading this data in a stat key, doing the comparison, picking the test, and then making a conclusion. And we're going to work on this pretty much every week till the end of the quarter. But next, we're going to do a couple more examples of this. Yeah, that's a good time for a quick